Yeah, that's not
Okay, I want to solve this, guys, for you two ways. I want to solve it for you using long division, and I want to solve it using reverse tabular.
Yeah.
Okay, so what's the difference between those two? So first, let's do long division. So first thing you're gonna do is 6x to the third power plus 10x squared plus x plus 8, and then
Ah,
what the heck was that?
I was surprised.
And then we have 2x squared plus 0x plus 1. Some of you guys are like, what? Where'd that guy come from? Hey, there was no x term. We have to have all of our terms in order for everything to line up exactly, methodically, neatly, blah, 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 blah. Do you absolutely need it 100%? Nope. But I'll give points for it if you do. Okay, so this is what we got to do. We got to look at our first terms. What multiplied to 2x squared will give me 6x to the third power? And the answer is 3x. And notice where I'm putting it. I'm putting the 3x right above the x. I like to keep the like terms lined up. And then I go 3x times that, 3x times that, 3x times that. What do I get when I do that? I get 6x to the third power. Then I get 0. And then I get 3x. And then I change all the signs so I can add them together. That's like how you subtract. Or how you can subtract. And then after that, I get 0. And then 10x to the second power. And then 1 plus negative 3 would be negative 2x. And then I'm going to bring down that plus 8. Finally, I look at this term, then that term, and I say to myself, if you multiply 5 times that 2x squared, you're going to get 10x squared. So that's what I'm going to do. I get 10x squared, then I go 5 times that, and then 5 times that also. And then I get 0, x, and then I get plus 5. After that, I got to change all the signs. So I change all the signs with the different colors because I'm teaching you, trying to get you guys to do that. Of course, you could subtract, but I don't like doing that because you might mess up with the negatives. And then I'm left with negative 2x plus 3. Is there anything else I can bring down? No. That means you're done. You just say plus negative 2x plus 3 over 2x squared plus 1. You put whatever you're dividing by on the bottom. And there is your answer. Now, chances most likely in the back of the book, you're not going to see the answer written like that. You're going to see the answer written like this. Do you guys know what happened here? I took a negative out of the top, put it in front, like this, and this is what you got on top now. This is most likely the way it would look in the back of the book. Now, if I was doing it reverse tabular, what I would do is I would go shabanga banga boogie boo, and I draw a big old box. Throw what you're dividing out onto the side. Notice I still have my missing term there, and that dictates how many rows I have. After you get how many rows you have, go ahead and throw out your arrows for the diagonals on every line and corner. Okay, so I got 6x to the third, 10x squared, and then I have a 1x. Okay, how many more terms do I have? I just have one more. See, this is the problem with what some students have with the reverse tabular method. They just have a problem setting it up. Now, I was anticipating more columns, but look at that. I don't have more columns because this has 3 terms and this only has 4 terms. Okay, but there's only one left, so I put the arrow in the middle, divided it up. Now let's go. Now, what number do I know inside right here? I know this one. Okay, don't put the 8 in yet. And the reason why I wouldn't put the 8 in yet is because we might have a remainder. Okay?
A reminder? Yeah, a reminder.
Okay, now, what times 2x squared would give me 6x to the third? 3x times 2x squared gives me that. Ooh. Okay, now let's fill in the rest of these because we just have to multiply 3 by those dudes to get them. All right, so we got 0x squared, right? S times x, but it doesn't matter because it's 0. And then 3x times 1 is 3x. We could actually find these two now because this guy plus this guy is supposed to equal this guy. And then this guy plus this guy is supposed to equal this guy. Everybody's cool? Everybody's cool? All right, well, let's just worry about the top one, okay? So, what plus that gives me that? 10x squared, right? 10 plus 0 is 10? Okay. All right, so what should go up here? What times 2x to the second power gives me that? 5.
What was it wrong?
5 times 2x squared gives me 10x squared. Is everybody cool? Okay, now 5 times this guy would be that guy times x. And then 5 times 1 is going to be 5. Oh, we have a problem here. What does that mean?
Remainder.
Right. Okay, so do the outside minus the inside.
3.
What do we get? 3. So we're going to say plus 3. And then also, did you guys notice this?
I did.
0 plus 3 does not equal 1.
Oh, dear.
So what is 1 minus 3? What is 1x minus 3x?
Whoa.
It's almost like it's the same. It's
Oh,
madness.
that's right. It is the same. So we have 3x plus 5 plus that crazy looking fraction thing. And if I take the negative out of the crazy looking fraction thing, it'll look like this. 2x minus 3. And then 2x squared plus 1.
You don't have to add the missing term there?
The missing term right here is only for like the work that we do. And the reason why I have the missing term there is so that this lines up. And this lines up. If the missing term wasn't there, the diagonals wouldn't line up.